Bismillahirrahmanirrahim. So today we are going to establish a relation between thermal capacity and specific heat. Okay, so let us write the equation for the two first. Okay, for thermal capacity the equation was like this: C is equal to Q divided by del theta. All right. For specific heat, the equation was Q divided by M into del theta. Now, you find the similarity, right? Q by del theta, Q by del theta. This part is same. So can I write it in this way, that 1 by M into Q by del theta? Okay. I can write this, okay. As it is in the denominator, it will be 1 by M into Q by del theta. I can write it in this way. Then 1 by M, let it be there, but Q by del theta, let us replace by C. So I can write it C here, right? So S will be equal to C divided by M. So this is one equation which relates the specific heat and thermal capacity. But if I want, I can write it in this way also. If the M is cross multiplied, okay, with S, then the equation will be C is equal to Sm. Okay, so now we know if you have the value of thermal capacity and the mass, then you can calculate the specific heat. And if you have the value of specific heat and the mass, then you can calculate the thermal capacity of the body. Is it clear?
Yes.
Okay. So these two equations we
Sir,
will...
আরেকবার বুঝান স্যার, লাভ করেন না।
Yes বলার পরে এটা বলে কেউ? তাকে yes বললো কেন? অদ্ভুত। এখন আবার লিখতে হবে পুরোটা। আরেকবার বোঝাইতে হলে শুরুতেই বলবা না?
স্যার নো নিড, আমরা তো ভিডিও থেকে লিখতে পারবো না।
এটা এইভাবে লেখা যায় নাকি আমাকে সেটা বলো। Q by m del theta, can I write it 1 by m into Q by del theta? Can I write it in this way?
Yeah. Yes.
So 1 by m, then Q by del theta. I will replace Q by del theta by C. So I will replace C here. So C into 1, it will be C divided by m. So S is equal to C divided by m. This is the equation to find out the specific heat if we know the value of thermal capacity and the mass. Now, let us say the specific heat is given and the mass is given. We need to calculate the thermal capacity. So we will just cross multiply these two. Then it will be C is equal to S into M. Now it is clear?
Okay. Thermal capacity by present.
Okay. The next topic that we are going to study is fundamental principle of calorimetry. Principle of calorimetry. Okay, so actually these are two rules. Fundamental principle means there are two rules which we will follow while we are solving the problem regarding this calorimetry. Okay, those two rules are when two bodies come into contact with each other. Actually this one I told you yesterday itself, that when two bodies come into contact with each other, one body will be giving up the heat, another body will be receiving the heat. So which one will give up the heat? Do you know? What parameter will decide that which one will give up the heat? What is that parameter?
Temperature.
Temperature. Very good, excellent. Okay, temperature will be deciding that which one will give up the heat and which one will receive the heat. Okay, the body with higher temperature will donate the heat, and the body with lower temperature will receive the heat. Now this donation and receiving will go on until
They are same.
the temperature becomes same. That means the thermal equilibrium is achieved. When the temperature becomes equal to each other, that situation is known as thermal equilibrium. So until thermal equilibrium occurs, the flow of heat will take place, right? The body with higher temperature will be giving up the heat, and the body with lower temperature will be receiving the heat. So that is the first. Okay, now this one is actually written nicely in the textbook that is with you, page number 180. Okay, fundamental principle of calorimetry. You can see that if you come to page number 180, it's not in the PDF that I gave you or the pictures I gave you. Okay, it is written in a better way in your textbook in page number 180. Okay, so there are two rules. If you see, the body at higher temperature gives heat to the body at lower temperature until they reach thermal equilibrium. So in short, if I write it, I can put it in this way: higher temperature body will give heat to lower temperature body. Okay, higher temperature body to lower temperature body. What it will give? The heat will be given. Okay, and up to what point it will continue? Until thermal equilibrium is achieved. Now, if I ask you what is thermal equilibrium, can you tell me which situation is called thermal equilibrium? I'm not writing any formal definition on the board, but I'm expecting that from the concept that I have explained here, you can actually say that when I can say that thermal equilibrium has been achieved or this situation has arrived. When I can say that? When
Temperature gets low.
temperature becomes equal. See, there are two bodies. Okay, I made them come into contact with each other. This one has a temperature of 50 degrees Celsius. This one has a temperature of 30 degrees Celsius. So as a result, what will happen? This body will donate heat to this body, and this body will be receiving heat from this one. So as this body is giving up the heat, the temperature of this body will come down, and as it is receiving heat, the temperature of this body will come up. So between 50 and 30, there is a point where the temperatures will meet, right? Let us say the temperature of 50 degrees Celsius body has decreased to 40 degrees Celsius now, and the temperature of 30 degrees Celsius body has increased to 40 degrees Celsius now. Now you can see that there is no temperature difference between them. The temperatures become equal. So if the temperatures have become equal, then we can say that we have achieved thermal equilibrium. This condition is thermal equilibrium. Anybody wants to say anything? Mahmoud?
No, sir.
Okay. So this is the condition of thermal equilibrium, and heat flow will take place when there is temperature difference. Now there is no temperature difference, no heat flow, so thermal equilibrium. Okay. So if I ask it in A for 1 mark, I hope you can write it now. Okay. So this is number 1. Number 2, we will not consider any heat lost. We will not consider any heat loss. The heat energy given up by one body will be equal to the heat received by one body. This is not actually the actual scenario. Okay, whenever somebody is some heat transfer is taking place, some heat always get lost in the environment. Okay, we cannot catch it. So but during calculation we will consider the ideal situation. So the amount of heat, number 2 point, okay, the amount of heat given up by bodies at higher temperature will be equal to the heat gained by the bodies at lower temperature. Okay, we assume that no heat is lost in this process by any other means. Okay, so number 2 concept is heat given, we can write it heat given or heat lost. Heat lost or heat given, same thing. Heat lost or heat given is equal to heat gained. This line is very important. Okay, based on this principle of calorimetry, we will be solving actually several numerical problems. Okay, so I would like to show you one problem now. Are you ready? Oh, Acha, before that, I need to take you through another topic, that is effect of temperature on change of state. Effect of temperature or heat on change of state. I need to take you through this. Okay, so these 2 points are clear. Very easy points.
Yes.
Yes, caller, পরে আমার কিছুক্ষণ wait করতে হবে. Anybody wants to ask anything?
No, sir.
Okay. Somebody take the attendance. Take this.
স্যার মাহমুদ আমার মধ্যে দুইবার আসবে মোবাইলে।
হ্যাঁ
স্যার আমি নিলে দুইবার নিতে হবে, কারণ নিচে না। মাহমুদ নিলে একবারে আসবে।
মাহমুদ নিলে একবারে আসবে, তাহলে মাহমুদ একটু নাও।
মাহমুদ এটা নিতে পারে, স্ক্রল শট বলে না একটি জিনিস।
ও অ্যাকচুয়ালি আমিও নিতে পারি, আমি তো ল্যাপটপে আছি। Okay, so effect of temperature on change of state. Now we know that. Let us talk about the state of the objects first. In how many states the objects can be? Do you know?
3.
3 states. What are they?
Solid, liquid, gas.
Very good. So 3 states we know: solid, liquid, and gaseous or gas. Okay. Now, if I want to go from solid to liquid, what I need to do? Do you know?
Heat.
I have to apply.
You should apply heat.
And from liquid to gas, I have to apply more heat. Right? So, but in between, what is happening? Let us try to take a deeper look. Okay. Let us consider the situation of water. Okay. We know that the solid state of water is known as ice, and the gaseous state of water is known as water vapor, and the liquid state is water itself, right? So when the situation or the state is changing, what is actually happening? Let us try to see. We will start from ice. Let us say I have the ice at minus 20 degrees Celsius temperature. I have the ice at this temperature, okay? Please listen carefully. You might be asking, sir, why did you take the temperature minus? Because at any temperature above 0 degree or at 0 degree, you will not, the ice will not be remaining ice, it will start melting down. I hope you already know that 0 degrees Celsius, oh, this one I told you already while teaching you the temperature scales, right? 0 degrees Celsius is the melting point of ice. At this temperature, the ice starts melting. Any temperature below that, the ice will not melt, which is the temperature of the deep freeze. Okay, we have refrigerator in our house, and some people have extra deep fridge. You know, the fridge that is kept in the cold store where they keep the ice cream, the box type. okay, fridge. So the temperature inside the fridge, it is below 0°C. That is why the ice cream remains, okay, in the solid state, or else it would have melted, right? So the temperature has to be below 0°C. So let us consider it is 20°C ice, okay. Now when I will apply heat to it, what will happen? The temperature will increase or decrease when I will apply heat.
Temperature will increase.
The temperature will increase.
Increase.
Now it will increase, then -20 to it will become -19, -18, -17. It will come towards 0, right? I hope you understand. Many people get confused.
Yes.
Is that
Yes,
the
integers.
temperature is increasing, then it should be -20 to -21, -22. No, that is decreasing. You are decreasing the further the temperature. Okay, it is easy to understand if you check it on the number line. I hope you all are familiar with this concept of number line. Okay, here it is 0, it is 1, 2, 3, it is -1, -2, -3. So any number that is on the right side will be greater, will be greater. So if I ask you, you are at -3, okay, then from here, any number you choose on the right side is greater than -3. So -2 is greater than -3, -1 is greater, 0 is greater, 1 is greater, and -4, if you are decreasing, then you will go on the left side. So that will be -4, -5, like this, okay? Achha. So from -20, the temperature is increasing, okay? Slowly the temperature is increasing, and at some certain point, the temperature will come to 0°C. 0°C, and it is still ice, okay? What will happen? What will start? The melting will start.
Melting.
Yeah, the melting will start, right? And you will see that even though you are applying heat now, the temperature is not changing. The temperature is not changing while the melting is taking place. So what will happen? 0°C ice, if I continue to heat it, what will happen? It will be converted into 0°C of water. What is actually happening here? When the temperature was -20°C, I was applying the heat. The heat energy was used to change the temperature of the body and bring it to 0°C. But when the temperature came to 0°C, I am still supplying heat energy, but the temperature is not changing. Why? Because the supplied heat energy is being used to change the state of the object. See, the heat energy that I'm supplying now is not being used to change the temperature. It is being used to change the state of the body. The ice is becoming water using the heat energy that I am supplying. So there is no heat energy left to increase the temperature. So when the whole amount of ice is converted to water and still you continue heating, then the temperature of water will increase again, right? I still I'm continuing to heat the water, okay? So all the ice has melted down and it has come down to water. So the water is at 0°C. I keep on heating it. What will happen? The temperature will increase now from 0 to 1, 2, 3, 4. Likewise, it will increase, right? And I will continue to heat it up to 100°C. So if I continue heating, what will happen? The 0°C water will be converted to 100°C of water. And again, I will see the temperature is not increasing. The temperature has come to at rest. This is one situation where the temperature came to at rest. And again, at 100°C, I will see that for some moment, the temperature is not increasing. What is happening? Can anybody tell me at 100°C, the water will start?
Boiling. Boiling.
That means vaporization has started. Here the melting was taking place and here the vaporization will take place. That means the water will start to convert into water vapor. So if you continue to heat this 100°C of water, if you continue to heat this 100°C of water, it will be converted into 100°C of water vapor. So again, what is happening here? You are supplying heat, but the temperature is not increasing. That means that heat energy that you are supplying is being used for some other purpose. What is that purpose? The change of state. The water is being converted into water vapor now. If you still continue to heat, then what will happen? When the whole water, all water has been converted into water vapor and you still continue to heat, then the temperature of water vapor will increase, and let us say I have heated up to the temperature of 120 degrees Celsius. Now we have a water vapor of 120 degrees Celsius. Okay, now this is actually effect of heat or temperature on change of
Sir,
temperature.
একটা doubt.
Hold on.
Sir, if we like heat it up to like 100%, 100 degrees Celsius water vapor, how will we heat it again? It's already water vapor, no?
Yeah, no problem. We can still heat it. Let us say when I have converted this water vapor and I have confined this water vapor into some kind of pot, I can do it, right? যেমন মনে করো এই যে তোমরা পাতিলে করে যখন পানি আমরা গরম করি, ঠিক আছে, কিছুক্ষণ পরে যখন ওয়াটার বয়েল করা শুরু হয়, ওয়াটার ভেপার উপরের দিকে উঠা শুরু করে, তাই না? এখন এটার মুখে যদি আমি মনে করি একটা বেলুন টাইপ কোন একটা শেপ যদি এটার মুখে ফিক্স করে দিই, তাহলে ওয়াটার ভেপার যেটা উপরের দিকে উঠবে সেটাই বেলুনটার মধ্যে কি হবে, কনফাইন্ড হবে, মানে জমা হবে বা আমি কালেক্ট করতে পারবো, তাই না? দেন ওইটাকে যদি আমি ফার্দার হিট করি তাহলে টেম্পারেচার ওটা বাড়বে। আই ক্যান ডু দিস। আর কি বলবো, ঠিক আছে, আমরা ওয়াটার ভেপারকে কিভাবে হিট করবো এটা নিয়ে, এটা তো কোনো বিষয়ই না আসলে, ঠিক আছে, অনেক টেকনিক আছে। যাই হোক, তো this is the full process. Okay, remember this one. At first the temperature will change of the ice, okay, but as soon as it comes to 0 degrees Celsius, the melting will start, the change of state will take place, and the temperature will not change, the temperature will not change. Okay, and then when it is converted to water, the whole ice has been converted to water, no ice left now, then the temperature will start increasing again, and if you keep on heating, at some point the temperature will reach 100 degrees Celsius. Okay, then again the temperature will stop increasing. What will happen? The water will be converted to water vapor without changing that temperature. So full water, when it is evaporated, then again the temperature will increase if you keep on heating. Okay, so understanding this process is of utmost importance. Why? যখন আমরা এখানে যে ম্যাথমেটিক্যাল প্রবলেমটা আছে এটা সলভ করতে গেলেই বুঝবা, সো এটা আসলে খুব ভালো করে বুঝতে হবে। ওকে, আচ্ছা, একই সাথে আমি দুইটা জিনিস আসলে একটু ডিসকাস করে ফেলতে চাই, সেটা হচ্ছে ল্যাটেন্ট হিট অফ ফিউশন। ল্যাটেন্ট হিট, ফার্স্টে আমি বলি ল্যাটেন্ট হিটটা কি। খেয়াল করলে দেখো আমাদের এখানে যে প্রসেসগুলো আছে, কখনো টেম্পারেচার চেঞ্জ হচ্ছে, কখনো টেম্পারেচার চেঞ্জ হচ্ছে না। যখন টেম্পারেচার চেঞ্জ হচ্ছে না তখন স্টেট চেঞ্জ হচ্ছে, তাই না? তো তাইলে আমরা এখানে যে হিট গুলাকে অ্যাপ্লাই করতেছি সেই হিট এনার্জিকে আমরা দুইটা ক্যাটাগরিতে ডিভাইড করি। একটা ক্যাটাগরি হচ্ছে যে হিট এনার্জি সাপ্লাই করার জন্য আমার টেম্পারেচার চেঞ্জ হচ্ছে, সেটা হচ্ছে এক টাইপের হিট। আর একটা ক্যাটাগরি হিট হচ্ছে যে হিট এনার্জি সাপ্লাই করার জন্য টেম্পারেচার চেঞ্জ হচ্ছে না, স্টেট চেঞ্জ হচ্ছে। আমি দুইটা ক্যাটাগরিতে ডিভাইড করলাম, তোমরা কি দুইটা ক্যাটাগরি বুঝতে পারছো? আবার বলি, নো প্রবলেম। আমি যে হিট এনার্জি সাপ্লাই করছি, অনেক হিট এনার্জি সাপ্লাই করছি না, এখানে টোটাল হিট এনার্জিকে আমি দুইটা ক্যাটাগরিতে ডিভাইড করতে চাই। একটা হচ্ছে যে হিট এনার্জি সাপ্লাই করার জন্য টেম্পারেচার চেঞ্জ হচ্ছে, যেমন মনে করো এটা হচ্ছে ফার্স্ট ক্যাটাগরির হিট, কেন এই হিট অ্যাপ্লাই করার জন্য আমার টেম্পারেচার চেঞ্জ হয়েছে। আবার এই যে এটা হচ্ছে ফার্স্ট ক্যাটাগরির হিট, কেন? কারণ এখানে টেম্পারেচার চেঞ্জ হচ্ছে, এই হিট অ্যাপ্লাই করার জন্য টেম্পারেচার 0 থেকে 100 হয়ে গেছে। তারপর এই হিট এনার্জি, এটা হচ্ছে ফার্স্ট ক্যাটাগরির হিট, কেন? কারণ এটার জন্য তোমার টেম্পারেচার চেঞ্জ হয়ে গেছে। এটা হচ্ছে লেট আস সে নাম্বার 1 ক্যাটাগরির হিট, আমি যেভাবে ক্যাটাগরাইজ করতে চাচ্ছি। ওকে, দেন সেকেন্ড টাইপ অফ হিট, যেটার জন্য টেম্পারেচার চেঞ্জ হবে না বাট স্টেট চেঞ্জ হবে, সেটাকে আমি বলতে পারি না যে এই হিটটা হচ্ছে সেকেন্ড ক্যাটাগরির হিট, এই হিটটা হচ্ছে সেকেন্ড ক্যাটাগরি। আমি এখানে রাখি যেটার জন্য টেম্পারেচার চেঞ্জ হচ্ছে না বাট তোমার কি হচ্ছে, স্টেট অফ দা অবজেক্ট ইজ চেঞ্জিং। তো এই যে সেকেন্ড ক্যাটাগরির যে হিটটা, সেই হিটটাকে বলা হয় ল্যাটেন্ট হিট। Latent heat, it is the second category. Second category means the heat which does not change the temperature of the body, rather it changes the state of the body. That heat is called latent heat. Understood what I meant by latent heat?
Yes sir.
TQ. When I mention latent heat, that means that heat will not cause any temperature change. Remember, I'm telling again, whenever I say latent heat, that one will not result in any change of temperature. So for latent heat, the change of temperature, in the answer you will look for 0. The change of temperature for latent heat, in the option you will look for 0 because no temperature change is occurring. So temperature change is 0. Very important. Okay, very important. Now this latent heat, we can see that two latent heats are here. Here we have one latent heat which converts ice to water, another latent heat which converts water to water vapor. So latent heat has two, I can say two types. One is latent heat of fusion. Fusion means actually melting. So here this heat is specifically named as latent heat of fusion. And the heat here, it is mentioned as latent heat of vaporization. Okay, this process here I can write it so that it is easy for you to understand: fusion or melting. Okay, and this one is called vaporization. Vaporization, or it is called evaporation. Evaporation. Okay, very important. You should take notes about this in your notebook. Okay, maybe not now, because if you take the notes now, then you will not be able to concentrate in my lecture. Okay, so please take the notes later by replaying the video if you can. Acha, so latent heat of fusion is this one. So whenever I ask you what is latent heat, you will write that the heat energy for which the temperature does not change, but the state of the object change, that heat is called latent heat. But when I say what is latent heat of fusion, then you have to say specifically. What you have to say specifically? The heat energy for which the solid object converts to liquid without changing the temperature. Like আমি কি বললাম, the solid object changes to liquid state. আমি specifically বলে দিছি এখানে যে মানে fusion হচ্ছে কোনটার জন্য, যখন solid state liquid state convert হবে without changing the temperature. That one is latent heat of fusion. Then latent heat of vaporization, এটাকে যদি আমি বলতে চাই তাহলে কিভাবে বলবো? The heat energy for which the liquid object changes to gaseous state. Okay, the liquid an object changes from liquid state to gaseous state without changing the temperature. Writing this one is very important. Latent heat এর এটা মানে দুইটা ইম্পর্টেন্ট পয়েন্ট, একটা হচ্ছে টেম্পারেচার চেঞ্জ হবে না, আর একটা হচ্ছে স্টেট চেঞ্জ হবে। এই দুইটা কথা তুমি ল্যাটেন্ট হিটের ডেফিনেশনে থাকতে হবে। যদি শুধু ল্যাটেন্ট হিট আসে তাহলে এই কথাটা লিখলেই এনাফ যে টেম্পারেচার চেঞ্জ হবে না, স্টেট চেঞ্জ হবে। আর যদি বলি তোমাকে ল্যাটেন্ট হিট অফ ভ্যাপারাইজেশন, তাহলে তোমাকে স্পেসিফিক্যালি বলে দিতে হবে কোন স্টেট চেঞ্জের কথা বলতেছো। আমরা জানি ভ্যাপারাইজেশন হচ্ছে কি ওয়াটার থেকে ওয়াটার ভ্যাপার হয়ে যাওয়া। ইজ ইট ক্লিয়ার? Is it clear?
Yes.
Okay. Okay. Very important to understand. অনেক ইম্পর্টেন্ট একটা টপিক ডিসকাস করছি। আচ্ছা, সো আচ্ছা টপিকের নামটা মুছে গেছে যদিও। ইফেক্ট অফ টেম্পারেচার অন স্টেট, এটার একটা গ্রাফ আছে যে গ্রাফটা তোমাদেরকে একটু বুঝতে হবে। This is temperature versus time graph. What it is? Here I will put temperature and here I will put time. So let us say this is minus 20 degrees Celsius, this is 0 degrees Celsius, this is 100 degrees Celsius. Okay, এই বরাবর একটা লাইন টেনে রাখি এবং এই বরাবর একটা লাইন টেনে রাখি। কেন এই লাইনটা টেনে রাখলাম একটু পরে দেখবা। Now let us say from minus 20 degrees Celsius temperature I have started heating the object. So what will happen? The temperature will rise. The temperature will rise and it will reach 0 degrees Celsius. See, for this time temperature change occurred, right? For this time, as the time is passing, the temperature is increasing. Then what will happen? As soon as it reaches 0 degrees Celsius, I know that the temperature will not increase for some minute or some time, right? What is happening? The time is moving forward, but the temperature is not going up or not coming down. It is remaining same for certain time. So এই টাইমটাতে এখানে কি হচ্ছে দেখি বলো তো অ্যাকচুয়ালি কি হবে যে যখন টেম্পারেচার ইনক্রিজ হয় না তখন কি হয় স্টেট চেঞ্জ হয় না এটাই তো তখন শিখাইলাম
Sir, melt.
the melting will take place, right? তো ফুল মেল্টিং হইতে তোমার কতক্ষণ টাইম লাগবে ঠিক আছে দেখো টেম্পারেচার ততক্ষণ চেঞ্জ হবে না যখন ফুল অবজেক্ট মেল্ট হয়ে যাবে and you still keep on heating then what will happen the temperature will start to rise again and what will happen the temperature will rise to 100 degrees Celsius. Okay, so this graph we are considering actually for water. Okay, okay, so 100 degree Celsius পর্যন্ত আবার কি হবে টেম্পারেচার বাড়তে থাকবে তুমি যত টাইম যাচ্ছে সামনে টেম্পারেচার বাড়তে থাকবে তো এই টাইমের মধ্যে আবার টেম্পারেচার বাড়বে then what will happen as soon as it hits 100 degrees Celsius again the temperature increasing will stop for some time.
Latent heat.
The temperature will remain constant for some time. Okay, so here what is going on? Which process is taking place here?
Latent heat, the change of state.
Change of state from which state to which state?
Boiling, water vapor,
Oil
water
to
to
liquid.
Water to water.
Water to water.
At 100 degrees Celsius, the water will start boiling and it will start to convert into water vapor. Then, after the whole water, all water has been converted to water vapor and you still keep on heating, then the temperature will rise further. So the whole process I have represented through this graph. This graph is in your textbook in the page number 177. Kindly come to this page and check the graph. Oh, I think we are done with the time, right? Okay, no problem. Alhamdulillah. Today, whatever I wanted to discuss, I have discussed actually more than that. Alhamdulillah. Okay, so as your homework, I would like to request you to go through the pages that I gave you as picture. Okay, like this page. Okay, this page. See, here it is written fusion, vaporization, and condensation. So what are
Page number?
Go through page number 108 from the picture that I gave you. Okay, and other than that, in your textbook, which is with you, okay, the blue color physics textbook that is with you, in that page number 176 and 177, also 178. Okay, kindly go through these 3 pages. Okay, inshallah next day we will solve a problem that is related to calorimetry, the basic principle that we just studied. Okay, according to that and combining that principle of calorimetry with the knowledge of this change of state, inshallah tomorrow we will solve a problem which is very important. এই বছর আসছে এই প্রবলেমটা সো এই বছর যদি কোনোটা আসে সেটা তোমাদের জন্য ইম্পর্টেন্ট বিকজ দিস ইজ 20 even number of year. So you will be appearing the board exam in 2022, which is also even number board year, right? So please pay utmost attention. Okay, acha, thank you very much.
Assalamu alaikum.
Wa alaikum assalam wa rahmatullahi wa barakatuh.